share the experience insight into the geothermal development across the region. Our first speaker is Dr. Heber Diez, the Strategic Technology Manager at TRIUM. He works with the Mexico Federal Electricity Commission, or the CFE, including serving as the field manager of the Cerro Prieto Geothermal Field. Today, he will discuss geothermal development and the exploration in the Mexico, technical lesson and opportunity for the future. And our second speaker is Anna Colvin. She is the Associate Senior Geoscientist at the Geologica Geothermal Group. Anna has worked on the geothermal exploration and project developed throughout Latin America. And today, she will provide a regional overview covering install capacity, active project, developed challenge, and as well as the financial opportunity. Following both presentation, we will have time for the question and the discussion. And thank you all again for joining us. And if the time is now ready, I will give the stage to you both. Thank you.
Okay, thank you, Travis. Thank you, Pon. Thank you, both of you, for the invitation and the opportunity to share experiences with the people, with the students particularly. Thank you to GR, and I really hope see you in Houston next Congress. And so let me share with you my presentation. Okay, I think there is, right? Okay. Thank you again. I will share with you about geothermal energy in Mexico, exploration and development. This was the topic that Pon and Travis asked me. And I am Heber Diez, as Pon mentioned. Actually, I am working for the TRIUM as a manager. I'm part of the Mexican Geothermal Association and the Geological Association in Mexico. But I'm more involved in geothermal projects for many years. I was working more than 18 years at CFE. But okay, at the first, we need to understand how is the context in Mexico regarding to geothermal. As you know, Mexico it's in the seventh place in the top 10 ranking for geothermal electricity. In the direct uses, Mexico does not appear, as we will see in the next slides, the reason why. But in electricity power generation, Mexico has been participation for many years in power generation. The beginnings, of course, in Mexico, we have some pre-Hispanic applications, Temazcal, something like that, direct uses with the ancient people here in Mexico. But if you think in the geothermal energy in the modern area, there was an engineer, Luis Fernando de Anda. This engineer visited Italy, Larderello, the geothermal field, and studied it, and brought the development of geothermal energy to Mexico, starting at the Pate geothermal field. That was the first geothermal field in all America. The first well that was drilled was in 1955, followed by 3 more wells, and those wells fed the first power unit, which comes from Larderello, of the 3.5 megawatts. It was commissioned in November of 1959. It never reached the rated capacity by many reasons, but this project becoming in the first geothermal electric project in American continent. Okay, after Pate Hidalgo, that was explored in 1949 and the operation in 1959, after Pate, Cerro Prieto was the second geothermal field that was explored by CFE, and it was explored in 1957, and the first commission was in 1973. At this moment, the geothermal field continues under operation, and it's the most bigger geothermal field in Mexico, and it's very important for the geothermal in our country. The next geothermal field was the Los Azufres. The Los Azufres is very nice geothermal field. If you have the opportunity once to visit, please do it. It was explored in 1975, and the first commission was in 1982. And the Los Humeros, Puebla, it's the other geothermal field. Is smaller than the Los Azufres, and it was explored in 1968, and the first commission happened in 1990. And the Las Tres Vírgenes was explored in 1987, and the first commission was in 2001. This geothermal field is the smallest one of the geothermal fields of the CFE, and which are under operation. There is a new one, the Domo San Pedro. This is the first geothermal field which is operated by a private company, Grupo Dragón in this case, and at the beginning was explored by CFE. After the modifications in the law, Grupo Dragón developed the part for the commission. Next exploration, next drilling, and finally a commission occurred in 2014, 2015, something like that. And we have Cerritos Colorados. This is part of the CFE. It's explored the geothermal field, but has some specific issues and there is no installed capacity at this moment. And there is a new one. This new one is Celaya, Guanajuato. There is a few public information. This is for another private company. And that I know is that is under exploration at this moment. Maybe some drillings. I am not sure really, because I repeat, there is no a lot of public information. But those are the geothermal fields that we have at this moment in Mexico. Some places or some geothermal fields under operation at this moment, other ones in exploration stage. This is installed capacity. This graph I took from a public presentation. This is of the CFE, and this not consider the installed capacity of Grupo Dragón and the installed capacity of PATE, but appears all the installed capacity regarding to Cerro Prieto, Los Azufres, and how was increasing with new additions of the power generations. The maximum power generation was around 720 megawatts. After 2010, we decommissioned in Mexico some power stations in Cerro Prieto, and we have this part of the paragraph, the graph, sorry, regarding to the power generation. And at the end, we were adding new capacity, the Los Humeros, the Los Azufres, and at the end, we have in this graph 927 megawatts of installed capacity, but from the CFE, just CFE. As I mentioned, does not consider Paten and Domo San Pedro. This slide shows you Paté, the first geothermal field, the Cerro Prieto, de Los Azufres, Los Humeros, Las Tres Vírgenes, and Domo San Pedro. It's very nice if you can see those geothermal projects. What about the geothermal fields in Mexico? As I mentioned, Cerro Prieto was the first one and is the bigger one at this moment. The location is in the north of the country, very close to the border with the United States in the Mexicali city. And the other one, the second one in the timeline, is the Los Azufres. This is in Michoacán state, very close to this part of the country. And the other one in the line, it's the Los Humeros. This appears in this area of the country. And finally, for CFE, the Tres Vírgenes. Domo San Pedro, it's located in this area, as we can see in this part of the picture, and it's the new one with installed capacity utilization in Mexico. What about the capacities? This information is public too. Maybe there is some inconsistency in the numbers, but it's more or less the right information regarding to the power generation. Cerro Prieto participates with 570 megawatts, de los Azufres with 252, de los Humeros 95, and de Las Tres Vírgenes with 10. Cerritos Colorados, and as I mentioned, there is no power generation at this moment, but the estimated potential is around 75 megawatts. The total of the CFE in this graph, in this table, it's 918. Plus Domo San Pedro, 25 megawatts of installed capacity. We have a total of 952 megawatts. There is a big potential yet in Mexico in the case for the high enthalpy projects, in this case, hydrothermal. In my opinion, and the opinion of the many experts, there is the other possibility with organic cycle ranking for the medium enthalpy utilization for those technology. And we have many other challenges. For example, we can use maybe in cascades in many places. We need to develop more the cascades and use the geothermal energy and maximizing the utilization, you know? And talking about just hydrothermal in this case, there is another possibilities as the direct uses, and of course for the new geothermal era that we have. And we need I'm talking about the hot dry rock. We need develop, we need innovate, and we need to do many things for develop all the different levels of the geothermal energy in our country. In this case, the potential, I took this information from a slide of a friend. The resources that we have now under operation, it's 959, more or less. We have some reserves, 215 megawatt, and we have resources, in this case, that we measured, something that we have indicated and something inferred. And you can see this graph. Okay. Based on the geothermal potential estimates conducted by CFE, we have the possibility of the 9 gigawatts, more or less, like you can see in this place. And for these reserves, we have the proven, probable, and possible reserves. For the CFE is this graph, this part, 9, 7 possibles, and the probable, it's around 2, okay? And if you can see, we have in this part of the table another information. This information corresponds to the Ministry of Energy, SENER, but it's more or less the same. Some extra numbers, but it's more or less the same information that we have in Mexico, with some possibilities. What about direct uses? CFE developed several pilots in the 80s and the 90s, but there is maybe one pilot working at this moment in one geothermal field, but there is no more direct uses projects at this moment. And the more recently, IDEA group, this is a group of the UNAM, has been developing and implemented several commercial scale and field test projects. That's the case of this picture. This was the hydratator for fruits, and it's very, very interesting what that group carried on. And I think we need pushing for more energy for using cascade. This is the case of the cascade application and other kind of direct uses. INEEL, this is another important institute in Mexico, has carried out some projects related to heat pumps. That's the last information that I have. At this moment, I am not pretty sure if they have some new developments, but maybe because they are under researching every day. And we know that we have significant potential that we need to develop. not only for cascades. We need apply heat pumps. We need to looking for different ways for use the geothermal energy. What about the medium and low enthalpies potential? We have this possibility for direct uses and binary cycles, as I mentioned. This information, it's maybe something old, but it's very important for this case. The direct uses in the worldwide and the potential in Mexico. At the end, we have a identify Trogan study from INEL, 927 localities with some anomalies of the thermal anomalies. And these thermal sites has in the surface, at the surface, 27 Celsius degrees, and the average surface temperature is around 41 Celsius degrees. The estimated temperature in the reservoir through the thermometry is around 60 and 150 Celsius degrees. This is important because this graph shows you that we have a big potential for this kind of applications in medium and low enthalpies potential. So if you have in the high, maybe you can apply binary, and if you are in the low level, you can apply for direct uses. You need design, you need to understand how is the reservoir, and design the way that you will be they do the utilization of the energy in this case. But anyway, this is regarding to the potential. And now, following the information that Tom and Travis asked for me, I put here an example of geothermal project development. In this case, I will focus it in hydrothermal because it's the traditional geothermal in Mexico. Definitely, we need to innovate. Definitely, we need looking for hot dry rocks. We need looking for more binary, different things. But in this case, and direct uses too, I will focus it in the high enthalpy projects, hydrothermal, of course. So we start with the development master plan. We need design, preliminary exploration, desk studies, and we need to try to understand what type of geothermal system we are going to develop. If it's conventional, if it's not conventional, is just heat applications, because now we need to understand that it's not only electricity, the energy is not only electricity, we can apply some things for heat. In this example, as I mentioned, we are going to talk about conventional high enthalpy hydrothermal application in a caldera type of reservoir. The exploration project, the geology, the geochemistry, the geophysics, and the reservoir engineering must be included at the beginning of the design for understanding in a deeply way. After this, we need to develop all the engineering, the basis and detailed engineering for find a drilling site, then drilling for carried on the drilling characterization and reservoir characterizations in the project. After that, we need to understand the well characterization test. In this case, if my well is for producing or for injection, I need to develop, design everything for try to understand in a very deeply way how it's working. Then we need to integrate all the geothermal system. In this case, in my example is flash, I need to understand if it's flash. If it's not for flash, it's for binary cycle. I need to understand everything for the binary cycle, you know? And at the end, I define that with that information, what kind of cycle I will use. And in this case, I have geothermal field development, drilling, constructions, surface systems, everything. And then I carried on the construction and commissioning of the power unit. I mean, I need develop the geothermal field, and I need develop the power station, you know? At the end, these steps definitely are for obtaining an efficient operation and maintenance. In this part, it's very important because I have the production, the injection reservoir management, the geothermal electric power plant, power energy, and associated products. I mean cascades applications. At the end, I need to carry out observation, monitoring, diagnosis, modeling, simulation, forecasting, and sustainability management. At the end, I have an efficient delivery, power, energy, and products. In this part, it's a continuous cycle. I need made observation and correct for be more efficient and in operation and maintenance, and this mix at the end contributes to have an efficient delivery of power, energy, and products. Identifying and characterizing the reservoir. Of course, I mentioned this is so quickly for you. We need put all the geology, the geophysics, the geochemistry, and the reservoirs for obtain conceptual model. In this case of the hydrothermal, of course, it's the same with a different point of view for the enhanced geothermal systems and the direct uses. We need validate. When I mentioned about the validate, this occurs when we have an exploratory drilling, and the next step is the development drilling. And we validate and refine the conceptual modeling with this information. When we confirm the reservoir through the well, we can see that we can obtain high enthalpy, ultra high enthalpy, or super hot or medium enthalpy reservoirs, or maybe hot dry rocks for EAGS. In this case of my example, we suppose that we find for a hydrothermal reservoir. And for this kind of reservoirs, usually we carried on some specific test. I show you one of those tests, pressure and temperature logging, interpretation, some specific analysis, geochemistry, interpretation of the geochemistry, production test, etc. But for what? What is the objective of all that information? Understand my reservoir, understand the chemical behavior, understand the thermodynamics, and with that information define high enthalpy, medium enthalpy, or direct uses. And this impact directly with the finance of the project. Design and construction. This stage is very interesting. We need design wells, injection well, production wells, injection wells, production systems, fluid transports, gathering system, electricity generation equipment, transmission lines, etc. And production and electricity generation in high enthalpy, as you can see, we put under operation. And as I mentioned, we need maintenance, we need monitoring, and at the end, to have a very high efficient in the production. As you know, these power plants could have a power factor around to 90% if you have a very good maintenance. So it's very, very important for the matrix of electricity. Production monitoring from the reservoir perspective, I always will share with people that you need to monitoring, understanding what is happening in the reservoir. And evaluation in surface, of course, all the phenomena that you could see in the surface coming from the reservoir, and you need to try to understand what is happening, what problems are occurring in every place, gathering, in vessels, in turbines. You have many tools, measurements, testing, modeling, numerical simulation, diagnosis, proposed and innovative solutions. This is a good example of the interdisciplinary diagnosis. I will try to be so quickly. You have some production variables, for example, mass flow decreasing, chemical clean of minerals, decreasing pressure and temperature. You have one input. You know about lithology, structures, mineralogy. You have maybe one input too. This well is similar to other well that you have drilled 25 meters away. with different behavior. So it's the same structure, it's the same part of the reservoir, but they have different behavior. What is happening? The measurements told you this shows you what is happening, and you need to formulate a hypothesis and observe all the connect possibilities. And these possibilities you need to try to understand. This is like a black box. This is white, but it's like a black box, and you need to connect everything, equations, hypotheses, everything, and try to understand what is happening. Then this is the part of the multidisciplinary importance. You as a mechanical, my case, propose this model with the people like geophysics and geological engineers, geochemistry engineers, and they put the information and connect with the reservoir characterization. And finally, we define a new one way for drilling next wells. So at the end, you confirm or refute your hypothesis, an improvement, and give sustainability to the system. This is important. Sustainability is planning. You have now very strong tools as the numerical simulation, numerical modeling, conceptual model, production variables you need to put into the model for obtain your thermal model, and of course predict the reservoir's behavior through many forecasts. Finally, not finally, but maybe, maybe yet, regulation. We have in Mexico new geothermal law was launched in March 18 of 2025. We have, of course, regulations of that geothermal law was published on October 3 of 2025. Introduced the new term permits for diverse uses and the exam geothermal utilization. Direct uses are practically this part, diverse uses. Geothermal financing and risk transfer program. At this moment is one project which is current. This was launched in August of 2018, financed from the IDV, coordinated with NAFIN, SENER, and CFE. And the objective is drill some specific wells in Mexico, some wells in the north, in Mexicali, and other one in the Las Tres Vírgenes, Cerro Prieto Geothermal Field. What opportunities I saw for new professionals in geothermal energy in Mexico? Enabling framework, new geothermal law and regulations. It's the framework which incorporate diverse uses and create more room for public-private collaboration. We need to understand, and we need definitely, I can see an opportunity for some kind of people in this place. Financing and active projects. We have CFE, Pemex, and private companies like Enal and Carso, and Grupo Dragón, of course. Some service companies, the growing demand of the geological, geophysical, and geochemical exploration outside of the CFE. We have this opportunity too. Training and community, universities, institutes, public and private companies, the collaboration, and Mexican Geothermal Association. We have an association and we can carry on vinculation, regional ties, Latin American associations, WIN, Women in Geothermal, various conferences, In demand technical areas, we have the exploration, geology, geophysics, geochemistry, reservoir engineering, drilling, and many other places in the specific places for diagnosis, direct uses. And direct uses for me is very interesting. Heat pumps, the irrigation, industrial cascading, and we have the possibility for introduce mechanical engineers, electrical engineers, all the disciplines that we have. Environmental engineers, among others, because the projects not only are in the technical part. Finally, conclusions. Mexico has an extremely valuable track record in geothermal energy, primarily in traditional hydrothermal systems. It's a geothermal power ranking 7, as I mentioned. However, it still needs to keep developing its potential responsibly. I mean, we need to understand in a very deeply way every system and innovate and develop more geothermal. As an example, Mexico, the geothermal resources yet not to be has an ample geothermal resources yet not to be developed across all enthalpy levels and reservoir types. An operational lesson, the geothermal system must be monitored and operated based on precise interdisciplinary diagnosis in order to give the process efficiency and sustainability. There are opportunities for different disciplines and every stage of the project processes, from exploration through operation and maintenance, as well as within outreach organizations, universities, institutes, regulatory offices, service companies, among others, as I mentioned. These highly specialized professionals are the ones responsible for giving geothermal projects long-term sustainability. This is in my opinion, a very, very important conclusion. And thank you very much. So sorry for the English. It's not my language, but I do my best. Thank you very much.
Thank you, Dr. Leon. That was fantastic.
Thank you.
Everybody, I know we probably have some questions from the audience, but we do have another presentation as part of this webinar. So I will proceed to let Anna Colvin present, and then we'll have some time at the end for questions and answers. If you want to, you can feel free to put your questions in the chat, but we'll have time at the end for an open question and answer session. So without further ado, Anna, feel free. And Anna, you're muted.
All right, how about now?
Yeah, that's great. And we can see it, and we can see the pointer.
All right, excellent, great. Thank you.
Or well, it's a mouse right now, but
okay. Well, hold on, we'll get it back. There we go.
Great.
All right, excellent. Well, thank you, Travis. Thank you, Bun. Thank you for Geothermal Rising, and it's wonderful to have an opportunity to talk with students. We were all in that position once, and different people along the way have helped us in our careers, and it's such a wonderful opportunity to be able to give back. So my name is Anna Colvin. I work as an independent consultant, and I also work very closely with the Geologica Geothermal Group, which is a consulting group out of Reno in the US. And we've worked recently on different projects throughout the Latin American region, most recently in El Salvador and Guatemala. And I thought it would be really interesting today to talk about Latin America on sort of overview on a broad scale, to give sort of a lay of the land, if you will, or a sort of snapshot of project development in the last, say, 5 years, you know, in terms of geothermal power production and direct use, and look a little bit about what are the challenges to geothermal development and what are the drivers behind this development. So I think first, you know, when we talk about Latin America, we're talking about geographically all the way from Mexico through Central America, the Caribbean, all the way down to South America. So it covers a huge region geographically. And this Latin American region can really be split into 3 sort of sub-regions. That would be sort of Mexico and Central America, South America, and the Caribbean. And each of these regions has such a different geography, geology, sort of social, political context that you really have to look at these sub areas separately. So, and it's important to understand that context, as it's sort of the backdrop of what's, you know, the geothermal development that's been taking place over the years. So let's look first at Mexico and Central America. Throughout the entire Latin American region, we have a lot of volcanic hosted system. In Mexico, we also have some extension. In general, there's a lot of good logistics, easy access, close to transmission throughout Central America. And it has a really well-developed electricity generation industry that's been operating since the 1970s. So sort of a long history of exploration and development, with operation happening mainly in the early days through these well-established state-owned companies in Mexico and CFE in Mexico, La Geo in El Salvador, ICE in Costa Rica. And there are also some private companies that are involved in Guatemala, Nicaragua. And overall, there are 6 countries which have electricity production, and there are 15 fields operating. So quite a lot of fields spread throughout. And the entire region contributes 1.7 gigawatts to the installed capacity that region, which forms a significant part of the grid, the electric grids, up to 22%. So, geothermal has played a really, really important role, I'd say, within the electricity matrix in this region. And there is some direct use, perhaps not as well developed compared to its capacity, which Heber alluded to. And it's often associated in cascade with some operating fields. And we'll look at that in detail. So in contrast, in South America, we have a really different geography that's dominated by the Andes Mountains. We have a lot more, long distances, mountain conditions, very remote geothermal systems. So that, presents a lot more logistical challenges for exploration and development than in Central America, where those conditions are a little easier. We also have some potential for co-production in sedimentary basins throughout the continent. I would say that most of the geothermal initiatives are sort of split between public, some private, and some PPP, so public-private partnerships. At the moment, we have power production in Chile and Colombia and Bolivia. And Brazil is sort of leading the region in terms of direct use. And in the Caribbean, completely different context. In the Caribbean, we have small island nations that the geothermal systems are almost all associated with volcanoes. We have much smaller geothermal projects, and therefore there's a lot higher exploration risk. There's also a limited power market on island nations that are largely dependent on fossil fuels. So very different context geographically and geologically, and we have 2 power plants on Guadeloupe and a new one on Dominica. So if we look at the graphs on the right, we have power generation here. You can see how Central America and Mexico are sort of leading the region, with Mexico with almost a gigawatt of installed capacity, whereas development in South America and the Caribbean have been hindered. In contrast, in direct use, we have South America leading direct use, driven largely by heat pumps in Brazil and Chile and Argentina, some in Mexico, but sort of largely underutilized throughout Central America. So we're going to have a look first at power generation, and then we're going to look at direct use. So here is a map of Latin America showing different geothermal power plants installed at the different geothermal fields in Mexico, the ones that Heber showed, many throughout Central America, Colombia, Bolivia, and Chile. So this would be South America, and then 2 power plants in the Caribbean. I think one takeaway from this graph or this map is that we have a lot of power plants located in Central America, and there's been I would say quite a bit of activity in the last 5 years, in terms of expanding and developing new fields, specifically in El Salvador, in Nicaragua, and Costa Rica. We have, in red, we're showing which are the either expansions or new power plants or wellhead generators, which have come online in the last 5 years. And then in blue, we have the projects which are still under construction. So in El Salvador, for example, we've had expansion of the Berlin plant. We have had 2 projects with wellhead generators come online. Nicaragua, we have an expansion. In Costa Rica, there's a large project underway for a new power plant at a new field. Guadeloupe, they're expanding a power plant there. Dominica, there's a new power plant that came online. Colombia, we have 3 different co-production pilots that have come online recently. In Bolivia, we have a wellhead generator project and sort of a larger project in the planning phases. And in Chile, at Cerro Pavillon, we've had an expansion. So there has been quite a lot of activity in the last 5 years, but it's still, not realizing its full potential compared to the significant resources that are available. And I think that development has really been hindered by a variety of challenges, obstacles that, are related, I don't know, to financing, to capacity building, to risk, that are sort of common region-wide, and also very specific issues in each country. And we're going to look at that, and then we're also going to look at, what are the drivers behind these different developments. And the multilateral banks have been really, really key in driving development forward, as have regulatory improvements in a lot of different countries. So first, we're going to look at these projects that are highlighted in red and in blue. We're going to look first in Central America and Mexico. So I mentioned that there are 2 power plants in Nicaragua at San Jacinto and the Berlin power plant, which have had bottoming binary plants installed in the last 5 years. So we've got 10 megawatts in Nicaragua, it's in San Jacinto here, and that's 7.5 megawatts in Berlin here. In El Salvador, we also have 2 wellhead generator projects that have come online, 5 megawatts at San Vicente and 5 megawatts at Chinameca. And at Chinameca, there's a 20 megawatt plant planned, which will be financed by the World Bank, and the same at San Vicente. There's larger power plants planned. At Costa Rica, there's construction is underway at Borinquen 1 for a 55 megawatt power plant, as we can see here. This is a project that's been in the works for a long time. It was delayed and then revived, and now has drilled a lot of wells, 7 production wells and 5 reinjection wells. And there's a second 55 megawatt power plant planned after that. And this is being financed by JICA. Mexico, we've already mentioned the risk mitigation drilling program. And then in Guatemala, there's also plans underway to reactivate exploration drilling at Tecumboa and Moyuda, also with World Bank support. Going over to the Eastern Caribbean, at Dominica, a 10 megawatt power plant at Rosso Valley has entered into operations this year, March of this year. It's currently in commissioning. So here's a picture of the well testing during drilling and the power plant there. Also very sort of long time in the works, very long project development timeline for this project, 15 years. It's being developed as a PPP between the government, so Dominica Geothermal Development Company, and Ormat, who has a 25-year BOT, and they also have a power purchase agreement, a PPA. In Guadeloupe, there's a geothermal power plant that has been operating for a long time. First geothermal power plant in the Caribbean, and there are plans to expand it from 15 megawatts to 10 megawatts. That power plant is currently owned and operated by Ormat, and they have already acquired a PPA for the additional 10 megawatts. There are also, throughout the other islands in the Caribbean, Nevis, Grenada, St. Lucia, there's plans to drill, supported by various international banks. So in Nevis, funded by the CBD, IBD, Saudi fund, there's plans to drill 6 wells later this year. Iceland Drilling has been contracted to do that drilling. Iceland Drilling has drilled a lot throughout the Caribbean and the region. In Grenada, they're planning to drill 2 wells, and St. Lucia, they're planning on drilling 3 slim holes. So a lot of activity happening there. Now we're going to go over to South America, and the last 5 years, 33 new megawatts came online for Cerro Pavillon. This is a 3rd unit of the first geothermal power plant in South America that came online in 2021. It's now generating a total of 21 megawatts. In Bolivia, at Laguna Colorado, Sol de Mañana, there was a 5 megawatt ORC plant that was being constructed in 2022, and there's a larger project. It's been under review for a long time, funded by JICA. And in Colombia, there are 3 different oil and gas co-production pilot projects. Each one in the order of less than a megawatt, 2 megawatts, co-producing fluids from oil and gas wells. And there's also new exploration that's going on. 3 exploration permits have been granted at Nevado de Ruiz, at Azufral, and at Paipa, which is significant because for a long time, there wasn't any exploration going on, especially at Nevado de Ruiz, which has been sort of stalled out, and looks like that is going to be picking up once again. So below here we have Cerro Pavillon, view of Laguna Colorado, and one of the pilot projects in Colombia, Las Maracas oil field. So in addition to the sort of active power production projects that are moving along, there are also a lot of projects that have been in works and have not moved forward for a variety of reasons. Heber mentioned Cerrito Colorado, which has large potential, but for environmental reasons and financing and political reasons has not moved forward. Here's a picture of it. At Sol de Mañana, I mentioned there's a large 100 megawatt project in the works, but has been delayed by politics, country situation. There's a market feasibility study underway to revisit that project. In Ecuador, Chachimbiro, there's a planned 5 megawatt plus 50 megawatt project. It's been very slow, also financed by JICA. The loan finally came through, and they're selecting a contractor to drill that project, but also been quite slow. In Argentina, there was a pilot plant that was installed in the 90s and then was not maintained, so it's no longer working. And that has a potential for expansion, but sort of stalled at the moment. And then in Chile, there are several projects that have been stalled out due to the power market. So changing gears, we'll have a look at direct use. Once again, looking at the 3 regions, this is a map of the entire Latin American region, showing the different applications throughout the different countries. In the Mexico and Central America region, most of the applications are sort of small scale agro-food, so greenhouses, food dehydration, fish farming, candle making, milk pasteurization, sort of many times associated with, in cascade with cascaded direct use associated with power plants in El Salvador and in Mexico. And in Guatemala, there's a sort of a mini industrial park. South America, there is the direct use applications are led by heat pumps in Brazil and Argentina and Chile. There are some other pilot projects for heat pumps in Colombia and Ecuador, and other sort of smaller scale applications, but generally involving heat pumps, greenhouses, fish farming, etc. And in the Eastern Caribbean, we don't have any direct use yet beyond bathing, though there has been feasibility study conducted recently by the Organization of Eastern Caribbean States. There is a lot of interest. So just to highlight on some selected initiatives, recent initiatives throughout the region. Heber mentioned in Mexico the IDEA Group at UNAM. There's also a food dehydrator at Domo San Pedro. There's a very nice project that was collaboration with the German GIZ. This was phase 2 of that project and provided in Central America regulatory framework support and really focused on developing demonstration projects and doing feasibility studies and working with the communities. And one of those projects was in Guatemala. It's entered into sort of phase 2 of the sort of transforming this mini industrial park at San Miguel, and they've sort of upgraded their facilities, and now they have cold storage. So it's quite an interesting project. At El Salvador and Lajeo, there's a organization called Funda Lajeo, which since 2006, so for the last 20 years, has been carrying out a variety of direct use projects and jointly with the local communities, ranging from coffee drying, milk pasteurization, candle making, etc. And there's a larger geothermal direct use heat plant planned at Chinameca with the World Bank project. There's that feasibility study I mentioned in the Eastern Caribbean that was carried out with support with the government from New Zealand. In Chile, SEGA is quite active in developing different projects using heat pumps, generally in pilot projects in rural areas. This is a greenhouse in Aysén in the south of Chile. And in Brazil, there's been also a push to develop new policies and legal framework to encourage more geothermal use. So I thought I would also mention next generation technologies because this is such a hot topic at the moment in the US and in Europe, but it's really sort of second level of interest in Latin America. I think the focus is still really very much on conventional systems. But there are, some research projects going on in EGS in Mexico and Brazil. There's, research project looking at EGS potential. Heber showed one of those projects. In South America, of course, Chile and Bolivia and Argentina are within the lithium triangle. And so there's been a lot of different research projects to see how, geothermal can support lithium development. Also in Montserrat, looking at critical mineral extraction. Touched already on repurposing oil and gas wells in Colombia. There's also huge potential in Mexico, of course. And green hydrogen is, very interesting for locations where you have research potential that exceeds your market. For example, in the Eastern Caribbean, so in Dominica, they have the 10 megawatt power plant, but they have more potential than 10 megawatts, which is, their demand. And so they're entered into an agreement to essentially export geothermal in the form of green hydrogen. There's also been studies in Chile about green hydrogen as well. So this is sort of like a area of, opportunity, but not as well developed. So we touched a little bit on barriers. There's a lot of them, which are really holding back project development. I think, one of the main barriers in Latin America is the power market. So the issue, at the heart of the issue, is geothermal has to compete with other renewables. And many of these other renewables, like solar and wind, are intermittent, whereas geothermal is firm power. So baseload on, baseload power, very high capacity factors. But because that doesn't do much for geothermal in terms of having to compete with these other renewables at power auctions or getting PPAs is quite difficult. So that's number one, I would say. Number two is financing, which is always an issue. And then, there's policy and regulation and institution capacity that those are sort of more longer term issues that are, depend on this individual country's situation. And then, of course, I think environmental restrictions, power auctions, political context is important. Remote locations, social context, different things that have to do with the specifics of that country. So the story is sort of similar in direct use, but I'd say the main issue with direct use in Latin America is financing, that these projects are generally smaller and they're a lot harder to find financing, especially at the early phases. And then the second issue, which is sort of unique to direct use, doesn't affect electricity production so much, is that there's a disconnect between the subsurface information, the potential, where those geothermal resources are, and then where the offtake is, where is the demand. So where is the industry that could, potentially be taking advantage of this energy, the source of energy for heating and other direct uses. So I think general lack of awareness, of course, regulatory issues and institutional issues, which are being addressed. So, what's driving the development to overcome all of these issues? It's really the multilateral banks, especially the World Bank, the Caribbean Development Bank, and the IDB. And, those banks working with, national institutions in Central America and Eastern Caribbean are really what's driving forward a lot of the projects at the moment. And they offer a variety of, these banks offer a variety of assistance on different levels, ranging from regulatory support, technical assistance at early phases, drilling risk mitigation, project finance later on. I also wanted to mention, I guess, so that and JICA also is, add JICA to the mix to that. There was a risk mitigation program that was going on for almost 10 years throughout Latin America, and that was the GDF risk mitigation program, and that funded 10 different projects over the course of 7 calls and surface studies and exploration drilling. But that project has been suspended. And there was a new project, new funding source from Project Innerspace to fund direct use projects. So, there's a lot of activity going on at the financing level. And then also the other driver, which is sort of more of maybe a silent driver in the background, is changes to the regulatory framework. So there's been a lot of changes throughout, the region, which is, anticipating that it will facilitate more development. So you can sort of split up countries into 3 different categories. Countries which have specific geothermal regulations, laws and regulations, countries which don't have specific laws, so they have, leave it to a diverse set of regulation in mining, environmental, water resources, electricity, etc. Geothermal doesn't fall into one category. And then the third category is in countries where geothermal development is done exclusively by the government, and so there really isn't much regulation. And we can see that throughout the 3 different categories, there's been advances in revising the laws, especially in defining, set of regulations around direct use, which has often been left out of specific geothermal laws, which have only focused on electricity generation. So in El Salvador, there's a new law last year, same as Mexico. And Chile also has revised their law the last couple of years. In Colombia, there's a new law. And then St. Lucia is looking to revise their law, as well as Costa Rica. So the last thing I wanted to touch on was some educational opportunities as we're coming upon the hour. I know we're a little bit behind, but maybe this is the most interesting aspect. So there, I think in Mexico, Chile, and El Salvador is really where there's the most opportunity in academics. So, uh, different academic groups in Mexico, same as in Chile. There's a diploma program in El Salvador, organized by La Geo and the GeoCTP from Iceland. It's a 5-month course for Spanish-speaking early career geothermal professionals. It was last held in 2024, so I'm not sure when the next program is going to be. Always a really good opportunity for those Spanish-speaking students out there. And then I wanted to mention that El Salvador and Guadeloupe are planning centers of excellence, so be on the lookout for more opportunities there. And then the last thing is there, a variety of associations throughout Latin America at sort of regional and national levels, as well as WING. There's different annual conferences, sort of finance-focused one, GLAC, which has been held for 12 years now. That was sort of has a political sort of financial focus, and so last year there was the first Latin American Geothermal Congress, which is a technical focus, and then there's annual meetings on the country level in Mexico and Colombia. There's 2 upcoming events which might be interesting for students. There's one in September of this year that's going to be focused on AGS potential, held by Association of Petroleum Geologists, and then Argentina is holding their first annual meeting in September. So September is a month with new opportunities. So with that, I'll leave it at that, and thank you for the opportunity. Here's my contact information. I'm happy to answer any questions. Thanks, Travis.
Thank you, Anna. That was fantastic. I mean, so much more information than I think I would have been able to find anywhere else. And it's great to have it all summarized in one place. And Heber, thank you also for your presentation. Everybody, I know we're over time, but Zoom doesn't have a limit. So if you do have questions, please feel free. We have one in the chat that I'll read out right now from Jordan Vesey. What are the largest companies to look into if we're interested in a job in geothermal in Mexico? So Heber, maybe this is for you, but Anna, feel free to chime in as well. I understand that CFE leads production, but is government owned. I'd love to know more about where to find jobs and internships, especially in business development and permitting.
Yes, just for the comment, yes, the biggest one is CFE in Mexico. But there is another opportunities that I see. Of course, the geothermal projects across Mexico should be development in the next years. There is another service companies that I can see they have the possibility to bring technology, to bring knowledge for exploration, then for design, power plants design, and wherever you want. Now, you mentioned, Anna, regarding to for example, Grupo IDEA is working in Pemex with direct users in the oil wells. So there is another opportunity directly with Pemex, but Pemex and CFE are public companies. In my opinion, there is another lay of opportunities with other services companies. I know that we don't have more time, but if you have the more questions, I think that is all. We can answer through an email or something like that, Travis.
Yeah, thank you, Heber. Ramon said to put Jordan's LinkedIn profile in the chat, and it looks like they're in contact, so which is great. I also wanted to ask Heber and Anna, could you are you comfortable sharing your emails in the chat in case folks have additional questions?
Yes, please.
Okay.
My case.
Great. And then Heber and Anna, I assume the answer is yes because you already shared them with me, but is it okay if I share the presentations with the folks who attended today?
Sure, no problem. I'll send you the version that I shared today.
No problem. Thank you.
Cool. Thanks. Yeah, Sia, go ahead.
Yes, thank you so much for your presentations, both of you, experts in the field, and it's so eloquently put in both of your presentations. I have a question for Heber. How do you actually settle disagreements between disciplines when a reservoir model doesn't match well behavior in the field? I'm a student, going to be a student in Ireland doing mechanical engineering, and I'm pivoting from environmental science to mechanical engineering. So this question will be really well suited for me. It's a bit selfish, but I would love to hear from you.
I will try to answer you. The main problem is most of the time that we don't observe. We are observing all the time what is happening in the system. Sometimes this is an example. You have prediction. You have a steam and quality. We are talking about thermodynamics, and some time appears declination so quickly. What's happening? Many people, for example, the geochemistry team, took some samples, analyzed, and they said, "Hey, the water is good. Okay, it's good. What does it mean that the water is good? It's good because there is no minerals, because it's clean, no problems with scaling. Okay, no problem with the scaling in the surface, right? So what is happening with the minerals? Because naturally you have minerals in the system, in the well. The minerals are into the well. So what is happening? A disconnection sometimes between the people who is operating a thermal well and the people who is designing the reservoir operation. You need to work together and try to understand together what is happening and find the problems, the issues that you have. So it is so easy. It's just communication, easy to solve. It's just communication, to be in the same table, in the same desk, discussing and talking about the problems. And let me share with you something. In my point of view, a mechanical approach, a mechanical engineer is very good because understand in a deeply way the thermodynamics of the systems. And sometimes when you put this variable of the thermodynamics with the people who is understanding the geometry and the behavior of the reservoir match, and then you have a very successful projects, in my point of view. Whatever you want, we can discuss about reservoir engineering. Thank you for
Yes, please. I will follow you up on LinkedIn. I'm so grateful. And I have another question, but I'll ask Anna or maybe on LinkedIn. I don't want to take too much time.
Thank you, Sia. Yeah, I think we maybe have time for one more question, but otherwise, I don't want to take up too much time for our attendees or our presenters. But yeah, Anna and Heber, if you guys could put your emails in the chat, and then everybody that's on the call, feel free to take those down. You can reach out if you have additional questions. I will send out their presentations later today or tomorrow at the latest, and then you can also follow up if you have additional questions about a specific country or a specific development or anything like that. We've got two real experts on the call from Latin America. Okay. Any other questions, anybody?
Thanks, Travis. I just wanted to mention I'm happy if anyone wants to reach out and also talk about career development, professional development. I know sometimes there are sort of non-technical questions or technical, non-technical, issues that come up, and I'm happy to share my experience with anyone.
Maybe I have like a quick question for like Anna, that like as you work in like many places in the South America, how you deal with like different federal regulation, and are you like looking for the local student as well, like if you are working on that place, or about the opportunity for a student in local?
Yeah, so what are the avenues for students to get involved in projects abroad, right? So that's the where this is going. Yeah. I'd say that there's definitely, opportunities for internships, summer projects. be on the lookout. Like now there's a lot of companies in the US that are hiring, I'd say sort of less so in Latin America, but because there are all these like World Bank funded projects, different bank funded projects, there's going to be more opportunity, but it's usually all of that is there's sort of a whenever there's a bank involved, there's a lot of bidding process and everything. So it's important to get connected with, a consulting company, or, it doesn't necessarily have to be a company in that specific country to have an opportunity to work abroad. Yeah. And the other avenue I would say is maybe reach out to some of the research groups in Mexico or Chile or El Salvador. As a student, I think, connecting with other students, other professors is, could be an opportunity to find out what things are going on more on a local scale.
Thank you so much.
Cool. Well, thank you, Anna. Thank you, Heber. Like I said, everybody, I won't take up too much more of your time. Sia, I believe you had some closing comments.
Yes, I do. Yes, Pun, Travis, Rusty, and Vanessa and I help with the social media and basically the outreach kind of work that we're doing out here. But yeah, my mind has exploded because like I'm from Kenya and Africa, East African Rift System. So, seeing that I can now engage with like the different systems that we see in Latin America. So I heard there's also a caldera you're talking about in Mexico. We have one in Menengai in Kenya. So I just saw a lot of collaboration, and we just really are so grateful for having this space for, young engineers, geologists, this interdisciplinary, multidisciplinary work that we're doing with such a beautiful system that this world has given us through the earth. And I'm just overall so excited, and I have so many questions. So I would love to use this time for questions, but it's definitely a wrap up. But I have sent you both a LinkedIn request, and I really would push all the students in this chat to please send LinkedIn requests. I would say that's how I was able to, propel my career. So I would say, yeah, overall, we're very grateful for you both, Anna and Heber. And I wish I could speak a bit of Spanish. I was going to speak French. No, I can't speak Spanish, but overall, so grateful. Yeah.
Thank you.
Awesome. Thank you, Sia. Thank you, Pun. Thank you, Anna. Thank you, Heber. And Rusty, I think, is on the call as well. Thank you, Rusty. Rusty's our advisor for the social media subcommittee that put on this webinar. So thank you, Rusty, as well, for all your help. And I will stop the recording, and we'll see everybody next time. We have, like I said, we have lots of events and opportunities coming up with the student committee. Follow us on Instagram or LinkedIn to learn more. And we have our monthly student committee meeting this Friday at 12 p.m. Pacific time. So see everybody then.